the first ownCloud conference I visited, I didn't organize, but I remembered one talk specifically, and it was from Hugo. He talked about doing the ownCloud server in Go. I think this was your bachelor thesis. And I was stunned because I was like, ooh, ownCloud is a cool project. And there's these super smart people coming there and giving talks on super smart stuff. Just to keep in mind, Go is such a young language, and Hugo was already deep into it at that time, so 4 years ago. Really awesome. Today, Hugo will show us at first what the Cern is actually doing with ownCloud, with their CERNBox. And in the second part, he will talk about service. Thank you very much. A warm welcome to Hugo, and have some great talks.
Thank you, Jan. Hello everyone, my name is Hugo. I am part of the Cern IT storage group, and today I will present what do we do with ownCloud and how we expanded ownCloud. So let's first begin about a brief introduction about Cern. So Cern is the European research laboratory that comprises more than 40 countries, and apart from discovering the Higgs boson, we also run the WLCG grid computing framework. So this is a network across different countries that provides computing and storage resources for all the scientists that form part of CERN. 20% of the resources are stored at CERN, but the rest, about 80%, are spread across all the globe. Just numbers, we have around 170 sites that are distributed in different tiers, like tiers 1 or tiers 2. We have around approximately 1 exabyte of storage distributed across all the globe, and scientists are really doing a lot of things. So they are submitting around 2 million jobs per day, and these jobs are distributed using multiple 10 and 100 gigabit interface. So said that, I will explain a little bit what we do with CERNBox in a smaller scale. So CERNBox is our cloud sync and share solution for CERN users. Is available for all CERN users. We provide 1 terabyte of quota. So we allow our users to synchronize the files, and also we give the possibility to have online functionalities. And it's very easy and convenient way to share data across user and groups thanks to the ownCloud sharing capabilities. All major platforms are supported, and is based on ownCloud and is powered by EOS. EOS is the open source storage system developed by Cern. And CERNBox is just not sync and share. It's a collaborative platform. So we have integrated with Office suites, for example, editing Office files, but also with scientific environments like Swan to perform web analysis from the web interface. So digging a little bit into the infrastructure, at the bottom you see that we have the physical storage, and EOS, the storage service, sits on top of this physical storage, providing a hierarchical view of the file systems across different clusters of thousands of storage servers, and also provides a rich ACL set. EOS exports different access protocols to the storage, like a POSIX file system, XRD access protocol for high-performance data throughput, and also WebDAP, and this is very important. What CERNBox adds on top of this is synchronization, sharing, mobile and web access. So just to give you some overview of the numbers of the service, currently we have almost 15,000 users registered into the system. We have around 670 million files into the server, and about the data volume, we have around 4 petabytes of data stored. Our users are coming from different backgrounds, so we have physicists, we have engineers, and we have people for services and administration. And our users are also very distributed. As you can see in the map, we have people working at Cern, working from different places across all the globe. So said that they can also work as a collaborative platform. So they can use tools like, for example, Office 365, so they can manipulate Office files. And we are also testing integrations with OnlyOffice and also with Collabora. They are also have the possibility, the users, to modify and create root files from the interface, so they can, for example, visualize graphs or 3D simulations from the collisions. So, what are the special parts compared to ownCloud from CERNBox? So, there are two main differences. So, the first one is the direct access to the storage. So, this is a normal ownCloud installation where we have user John here accessing the ownCloud server through the web interface, and he can list the files, upload the files, etc. But now, imagine that you want to give the users the possibility to access the storage directly. For example, through a WebDAV mount, or for example, through a Samba mount. So the user will write to this storage, and then ownCloud will use a background synchronization job to make sure that the data that has been added behind ownCloud is synchronized into this OC file cache. So for example, given the volume of data that we are managing, this was not possible. So we take a shortcut. So the shortcut was to remove this OC file cache dependency and rely on EOS for storage. So EOS provides the synchronization, features of ownCloud. So now user John can access the web, uploads a file, the file is in the storage, but the other way around is also possible. So the user can mount the storage, manipulate the storage, and automatically the changes are also provided in the sync clients, are also provided in the web interface. Another feature of CERNBox compared to ownCloud is the following. So in this use case, imagine that Ion shared a folder with rows. So for rows, the only way to access this folder is to pass through the ownCloud server using a sync client or through the web interface directly. But the rows cannot access the shared data from user John directly. She cannot mount a Samba share from another user because the Samba share doesn't know about ownCloud permissions. So for us, it was very important to make sure that users has a universal access to the data. It doesn't matter what is the access mechanism. So what we have done is, thanks to EOS and the rich capability set, we can allow users to mount other people's storage. So in this way, you have an integrated way to access the files in your storage system. So, but this, of course, is not for free. So over the last 5 years, we have been hacking and patching the ownCloud core to make sure that this integration with EOS to provide these use cases was possible. And thanks a lot to ownCloud because the collaboration has really been really fruitful in the last years, reducing the number of hacks a lot. But last month, we decided that to upgrade in easy way to the next version, etc., to take a different approach. And the approach we took was to take these hacks and put it in a completely different server. So this is very similar of, for example, if you use ownCloud with S3, where the uploads, when you want to upload the file, the server will redirect you to a storage element. So we did the same, but not also for storage, but for sharing. So we have our own sharing and storage server that redirects the puts and all OCS requests that relates with the creating of shares, manipulating of shares, to this component that is called the Riva server. And Riva server is a gRPC and Google protocol buffers implemented in Go for a high performance that supports all the OCS and WebDAV operations. So just to finish, to give you an overview, so CERNBox plays a key role in the future home directory service for Cern. We are trying to combine all the storage services at Cern into one, relying on CERNBox and ownCloud. The use of the service is really skyrocketing. Compared to last year, we have a growth of 400%, and users are demanding more and more features every single day. We have a really nice collaboration with ownCloud on different projects, on ownCloud Mesh, this year on the Google Summer of Code with Phoenix that will present it tomorrow, on the ownCloud Foundation, and we really want to keep it rolling. And that's it. Thank you very much.